Hi guys, another homemade video from Megan. So I wanted to talk about the last algebraic method that's commonly used in algebra for solving systems. It's called elimination most commonly. It can also be referred to as linear combinations. I think it's listed as linear combinations in the Common Core State Standards. But it's hinged on this idea that you can really do anything to an equation as long as you do the same thing to both sides. So if we view an equation as two equal things, if we say that this is equal to this, meaning they're the same, even if they don't look the same, you could technically add this to one side of an equation and this to another side of an equation, and you'd be adding the same thing, right? So these two are equivalent, therefore I can add them. Some students really love this method. It sort of harkens back to a time of doing that vertical addition problem from elementary school, so they do like it. Problems sort of have to be set up with the equal sign aligned, and then things have to be added sort of where they are on the side of that equal sign. So this type of system is perfectly set up for linear combinations or elimination because we sort of have that alignment. I have seen students work with equations that are formatted differently, and they just sort of move it around until they get what they want. But this is the most common type of elimination problem. So if we look here, if we added these together, we wouldn't actually eliminate any variable. The key here is to get rid of one of the letters. So I find that this works best with students who sort of have that innate ability to recognize math facts. They're pretty simple math facts, but it can work for any student. I'll show you sort of how in a moment. But so I'm going to look at these two here. I'm going to notice that 4 and 8, right? I can get this to eliminate with this only if it's a -8, meaning a -8 and a +8 will cancel each other out. So I can get this to be a -8 by multiplying, right? So I'm going to multiply this whole entire equation by 2. Let's remember that because an equation is balanced, if we do the same thing to both sides, it will remain balanced. So what I end up with for this top equation is -4x minus 8y equals -44. This is the most commonly missed step. Students, they do okay multiplying these, but they're so not used to that process of multiplying across an equal sign that they skip that part. They think of like sort of like that distributive property piece, but they forget to distribute to the whole thing. That's why I sort of have them draw all 3 arrows. The next equation, I don't really have to do anything to because I already have this +8 hanging out. So I end up with +3x plus 8y equals 43. These I can then combine, okay? What I'm left with is, like, this is what I was saying, how it's like sort of that vertical addition problem where you're sort of like adding down. When I add these together, -44 plus 43 is -1, right? -8y plus 8y, that was what we were going through for. That eliminates, that's where that name elimination comes from. -4 plus 3x gives me -1x. Okay, so I'm really close to a solution here. Divide by -1, get x equals +1. Okay, that is my x value. Like we said, you're looking for a point of intersection between these two lines. These would be super gross to graph because I'd have to solve for y, or I'd have to graph each one by using its intercepts. So it's really nice for elimination, but I can substitute back in to one of my initial equations. I'll choose the second one because it doesn't matter. 3 times 1, because I know x is 1, plus 8y equals 43. I can plug that x back in to get that y. Subtract 3 from both sides. Again, not going to spend too much time here because you guys are on it with the equations. Divide by 8. I don't always show that step. Y equals 5. So my intersection point for this would be 1, because that's my x value, comma 5. We've used sort of that combination of elimination here and substitution here. That's what I'm most comfortable with. I will show you another method for students finding this second value though. If they wanted to do elimination again, I'll show you a different way they could have done elimination. I have had students who are so good at this that they're like, can I eliminate for X and then can I eliminate for Y? And that's totally an option. I'll show you how that elimination for Y is done. It's a little more complicated, but again, some students really love this method for whatever reason. I had a student who would do everything in her power to get to elimination. So if we wanted to eliminate the X's, again, I can't make a 2 into a 3 with multiplication. Like can, but it'd be really, really ugly. But what I can do, and this is where this can work for all students, is I can multiply the top by -3 to get to a -6 and the bottom by 2. You can always multiply both equations. With students, a lot of times I'll use highlighters. I'll make sure it's one at a time. I'll have them cover it up so that they don't mess up anything. But that idea of multiplying the top by the bottom and the bottom by the top is a great one for students who maybe don't recognize 4 times 2 is 8. They could do this times 8 and this times 4. It would still work. The numbers are just going to be really big, but they will still eliminate. And one does have to be negative. I have had students that sort of forget about that, and then when they go to add them, they're like, oh, I have to make everything negative, or change the signs on everything. So we end up with -6x minus 12y equals -66. And then down here we end up with positive 6x, 2 times 3, positive 16y equals positive 86. Okay, again, this is just an alternate to find the number 5, or if they wanted to start out this way and find y first, it will work. There's a lot of different ways. There's actually infinite different ways you can do this. So when I go ahead and add these together, you'll notice the x cancels. -12 plus 16 gives me positive 4y. That's the part that students find the hardest, because integer work is really hard for our middle school students. You know, if they're getting all the way here, I do tell them to use their calculator a lot of times. It takes that part out of it, so that they can get to the heavier math without that integer work really holding them up. You know, there's a time and a place to work on integers. This may or may not be it. When I add these together, I get 20. Divide by 4. Shoot, I mess up integers sometimes, right? And we get that y equals 5 that we knew from substitution was the answer. So again, there's multiple ways to do this. I've seen students multiply by like crazy things to get to a number that will cancel. Again, this top by bottom, bottom by top will always work, but if you get to a number that cancels and you have multiplied through by the same thing each time, it will always kind of divide out in the end to give you what you were looking for. So that's elimination. It's not my favorite method, but it is some students' favorite methods. I will tell you, I have had the best luck having them copy each equation next to itself, whether they modified it or not. So notice in this problem, we modified both of them, so that made sense. But I do think it's really valuable even if they're only modifying one, for them to rewrite the second one, so that they just have a clean new space to work with. That's elimination. Let me know if you have any questions about it. Again, if you work through an elimination problem and you get something like 5 equals 6, okay, that seem like, oh, that doesn't work, that is a no solution. Or if you get something that does work, okay, if you're working through not in this problem, if you're working through an elimination problem, that's in all real numbers. The other one that comes up a lot in elimination or substitution is you'll get something like x equals x. That's also always true. That solution will be all real numbers if that came up algebraically. One of the things I like to show students, the shortcut to writing all real numbers is a little r that looks like that. They like it. It's very mathy. It's just shorthand. So for those of you who like to nerd out with notation, that's another little fun one.